In our next question, we're given a graph of a function and asked to determine the inverse graphically. Well, this next question, our function is linear. So, in order to graph it, it is convenient to have 2 points on the straight line. We choose -4, 2 and 5, -1. We know from experience that in order to accurately graph a straight line, we only need those 2 points. Now, to determine the inverse, what we do at first is we take the point -4, 2, switch the x and y coordinates, and graph 2, -4. Also, we take the point 5, -1, switch the x and y coordinates, we get -1, 5. And now we realize the original function was just a straight line in between these 2 points. The reflection of a straight line is another straight line. So we're going to draw a straight line in between the 2 red points. That's what we get. And if we look at the dotted line y = x, we see that the green line and the red line are actually reflections. If you were to view this green line up to here and reflect it in the diagonal line, we would get the red line. And similarly, if you were to see this this portion of the green line and reflect it in the line y = x, we'd get this portion of the red line. It is a reflection. Now, we're asked to state the domain and range of each of these, and so we have on the green line, the domain is the set of all x element of the reals, and the range is the set of all y element of the reals. Well, since the domain of 1 corresponds to the range of the inverse, then the range of the inverse should be set of all y element of the reals, and the domain of the inverse should be the set of all x element of the reals.